So we have the integral of cosecant squared x dx. So what's the value of that? Well, before we do anything too crazy, right? Before we go crazy with substitutions and stuff, I want to point out that cosecant of x is kind of like the cofunction of, well, not kind of like, cosecant x is the cofunction of secant x, right? And we know, or we should ideally know, because I think this is a standard integral, that the integral of secant squared x dx is equal to tan of x plus c. So we should know that. That's a standard integral, I think. So I'm not going to actually do really any special integral techniques, or not directly at least. I'm more of going to kind of use this fact to evaluate this integral, if that makes any sense, right? So basically what I'm going to do, because cosecant x is the cofunction of secant of x, we can rewrite this integral as the integral of secant squared pi over 2 minus x, because that's what a cofunction means, right? Now, well, that's what we're basically almost done. Really, we can do a u substitution, right? We can say that u is equal to pi over 2 minus x, right? And then, I mean, what we could do really is put a negative right here, a negative on the outside, to create a multiplication by the derivative of pi over 2 minus x, because I mean du, it really is negative 1 times dx, right? So we can take a negative 1 and dx and lump them together into a du, and then do a substitution, right? So we'll really get the integral, it's a negative integral of secant squared of u, so secant squared u du, right? And from this fact, we know that this is equal to negative tan of x. Well, yes. From this fact, from the fact that integral secant squared x dx is equal to tan of x plus c, we know that this integral, like with the negative and all that, comes out to negative tan of u plus c, right? But original integral was in terms of x. We should probably get our final answer in terms of x. We know u is equal to pi over 2 minus x. That's what we set it equal to. So we'll end up with a final answer without simplification. We'll do some simplifying. We'll get negative tan of pi over 2 minus x plus c. And we have a pi over 2 minus x as an argument for a tangent function. So we can just rewrite this as a cofunction. So we can rewrite our final answer, fully simplified, 100%, as negative cotangent of x plus c. So yeah, pretty simple really. Basically like the brother of integral of secant squared x dx, right? Answer is kind of similar really. I mean, you have secant squared x, cosecant squared x. If we have here we have a tangent of x, here we have like some cotangent of x. So if I were you, I'd probably want to memorize this too, but if you forget, derivation's like really quick, right? Evaluation, whatever you want to call it. So really, yeah, not too bad. And stay tuned for more cool stuff.